Hey mathematicians, today we are going to talk about the conditions that you need to meet in order to have a triangle. We know that a triangle is a three-sided closed figure, and you can see here I have some line segments pinned to this paper that we can hopefully use to make a triangle. My top line segment is 7 units long, this line segment is 6 units long, and this one is 5 units long. You can see that if I swing these line segments together, I can make the ends match up, and it does create a triangle. This one works. Here I have another line segment of 7 units. This time, my two sides here are 3 units and 3 units. If I swing these inward, you can see that I cannot get the endpoints of these line segments to match. There's still a gap in the middle. So this one will not create a triangle. Here we have a third set of line segments. My top is 13 units, this one is 6 units, and this one is 7 units. And it's getting close to a triangle, but when I rotate them into meet, the only time the endpoints actually meet is when they completely overlap that line segment. So this is not a triangle either. These have to be a little bit longer. And that brings us to the triangle inequality theorem. Any two sides, when you add them up, their sum has to be larger than the third side. 6 plus 7 is equal to 13, so it won't make a triangle. If either one of these sides had been a little bit longer, such as 7 and 7, or 6 and 7.5, we would have been able to make a triangle out of them because they would have met just a little bit off of that line segment. Here's another set of line segments, and we can check to see if this will create a triangle even without moving the manipulative. If 6 plus 5 is greater than 3, and we know it is, and 5 plus 3 is greater than 6, and we know it is, and 3 plus 6 is greater than 5, which we know it is, we know that this can create a triangle. In other words, we checked the sum of two of the sides for all the combinations, and every time it was bigger than the third unused side, which means we can definitely make a triangle out of it. Here we have the triangle inequality theorem written out. A plus B must be greater than C, A plus C must be greater than B, and B plus C must be greater than A for any triangle with side lengths A, B, and C.